All right, so today we're going to work with lesson 412, decimal and addition algorithms. So we're going to review whole number addition algorithms and use them to add decimals. We're going to understand the place value system, and we want to be able to perform operations with multi-digit whole numbers with decimals to the hundredths. Okay, so we're going to ignore that. Let's go down to here. Okay, you're going to write the decimals in standard notation and in words. Okay, so when I add these together, I see that I have 2 and 49 hundredths, right? So could write it as 2 and 49 hundredths, and then I could write that in words, and I'll let you do that. But this one here, you see I have 7, and then I have a 3 in the tenths place, and a 1 in the thousandths. Okay, and again, you want to write that in standard notation, which is just number form, and then also in word form. Okay, so you can do these as well. So a lot of times people forget what standard notation is. That's just where you're adding them up and writing the answer. So a couple words that we'll see today is accurate, as correct as possible for the situation. So if something's accurate, it's as close as possible, or it's correct. Okay, algorithm is a set of step-by-step directions for doing something, such as carrying out a computation or solving a problem in math. Column addition is a method for adding numbers in which the add-in digits are first added in each place value column separately, and then 10 for 1 trades are made until each column has only one digit. Lines are drawn. And then partial sums addition is a way to add in which sums are computed for each place value, ones, tens, hundreds, and so on separately. The partial sums are then added to give the final answer. U.S. traditional addition algorithm, an addition method that involves adding digits by place value columns starting at the right. Okay, so you're going to use this strategy to solve. Okay, so you can see what they did here. It's just our traditional, not traditional. First, they added up the hundreds place. Then they went to the tens place in the next row, and then they did the ones. Okay, so let's try that method. Again, not my favorite method, but this is partial sums. So I'll at least show you. So 2 and 84 hundredths plus 4 and 35 hundredths. So in this case, I'd add up the ones. So I'd say 4 plus 2 is 6. And then I would say add up the tenths, and I get 8 plus 3, which is 11. So I'd actually put a 1 in the tenths. And then over here, I'd put a 1 because it carries over. And then I could put a 0 here. And to me, I think this just makes it more confusing. But again, I have to show you at least how to do it. So if you prefer this method, again, I think this algorithm just makes it more challenging. And then I add the thousands, okay, hundredths, and I get 4 hundredths plus 5 hundredths, which is 9 hundredths. And then I could add those together, and I get 9. I should get 7 and 19 hundredths. Okay, and for me, I prefer to just line up the decimals and just add traditionally the way we've done it, but I have to at least show you again that. Okay. So a common error with that is just the alignment, right? So I mentioned this in previous lessons. You have to line up the decimals here. Okay, and here you can see they did 6 over here, and they actually put it over here where the hundredths would be. Here they did 8 and 3, so 11, which is fine. Or actually, no, yeah, that one's okay because the one, it's in the ones place in the tens. And then the last one they did there. So that 6 was in the wrong place for partial sums. Again, I think it's more confusing to do it that way. Another common error they're telling us is when you take like 9 and 1 and make it 10 tenths. And no, that's okay. So again, I would avoid, honestly, partial sums if possible, because really adding decimals is just simply adding and then bringing down the decimal. Well, partial sums addition is an example of an algorithm for addition, just as partial products multiplication, traditional multiplication are algorithms for multiplication. Algorithms are useful because they define a set of steps that can be applied to solve many different problems. Most whole number addition algorithms can be adopted to add decimals, and today you'll explore 2 more algorithms you can use to solve decimal addition problems. So you're not together on there, so we won't do that. But here's some more information. So all 3 algorithms are reliable methods for adding decimals. When deciding which algorithm to use, you should consider 2 things: accuracy and efficiency. So which one's going to help you get the correct answer every time, and which one is going to be getting the answer quicker in just a few steps. So to me, I think partial sums is harder to be accurate and efficient, in my opinion. Which algorithms might help you get an accurate answer? So you could do partial sums, or you could do traditional addition. Again, we've all kind of learned traditional addition since we started adding numbers, right? So everyone has different answers to these questions, and it's fine for each person to choose the algorithm that works best for them. So if you really like that, partial sums, you can do that. To me, I think it's just confusing. So first, let's make an estimate, right? Because that tells us if our answer is reasonable. So if I look here, I think of this as money, $8.30. It's closer to $8 than it is to $9, right? And $7.24, if you think it that way, it's closer to 7. So my answer should be around 15. And so I'm going to just go ahead and model traditional because, again, that's easier for me. You will always put the decimal and then build your number around it. Okay? So don't worry about lining up the numbers. Line up the decimals first. And 5 and 4 is 9. 3 and 2 is 5. 8 and 7 is 15. So I get 15 and 59 hundredths. And if you look at my estimate of 15, that's pretty close, right? So my answer is reasonable. So as far as the estimate, I could have rounded each decimal to the nearest whole number like I did. So I did 8 and 7. We got 15. Oops. You could have added the whole number part of each decimal. So 8 and 7, got 15 that way as well. You don't have that, but let's look at Math Journal page 146. So one that, let's see if there's any there that I really want to point out to you. Number 6 always seems to be a trickster here for people. So if you look here, you have it all the way to the thousands, here only to the hundredths. Add a 0 there and it makes it much easier. So whenever I do the work here, I want to make sure I do my estimate. So in this one, I'll do 2, and it's closer to 8. So I'm going to say 2 plus 8 is 10. And I'll model this one, and then I'll let you do the rest. So 2 and 3 tenths plus 7 and 6 tenths. I bring my decimal straight down, and I get 9 and 9 tenths. Okay, so at this point, you want to pause the video. Make sure that you have done each of these, get an answer so you can check it against mine. All right, so you should have paused the video and you should be getting your answers here. So you can check your work against what we have on here. Again, sample answer because your estimates could all be a little bit different. So again, if your estimate doesn't match theirs exactly, but it's close, and it make sure your answer is reasonable, that is acceptable. All right, on the next part, you want to choose one problem, answer the questions below. How did you make your estimate? How did your estimate to check your answer makes sense? So you need to explain in those two, and that's your own thinking there. So then you're going to look at page 147 for your math boxes. So at this point, you want to pause the video and go ahead and try to work on that. All right, so if you're back here, this says put them in order from the decimals in order from least to greatest, right? So the one thing I notice here, this one goes tenths, hundreds, thousands, 10,000. So I'm going to add zeros all the way over just because it helps me visualize a little bit better when I'm comparing them. You don't have to do this, but I find it helpful. So then when I look here, the one that's the least would be this one to start with, right? Because it's all zeros all the way until you get to the thousands place. And then I'm going to look for the one that's the greatest. Well, this one has 7 and this one has 7. But if I look in the tens place, the 1 is greater than the 0. So this one would be the greatest, and then I have to place the other 2. And you should have got that. Okay, and then exponential notation. Remember here, you would put the whole number 3. And then you count your zeros. 1, 2, 3, 4. So it'll be 3 times 10 to the 4th power. So make sure you fill that in before you look there. Evelyn is going on a hike. She will hike 4 miles in all. So far, she's hiked half of the total distance. How far has she hiked? So again, we want to use cubes here, right? So she will hike 4 miles. So far, she's hiked 1/2 of it. So I could set up an algorithm here, 1/2 of 4. And I know that when I do a fraction of a whole number, I want to multiply straight across and then divide if I have an improper fraction. Okay? So you should work that out now. Get your answer if you haven't already. And then write the decimal in word form. So remember, this is the, oops, so you can see it there. Make sure that you have done that. And remember the THS for the decimal place values, otherwise it'll be counted wrong. And then number 5, Sarah said that 10 to the 4th power is the same as 40 because 10 times 4 is 40. Explain why she's wrong. So here it's telling you she's wrong. You got to tell us why. What did she do that was incorrect? Okay. And then you can go on to everyday math and you can play fraction of to wrap up the lesson.